Hello everyone, my name is Roger, and welcome back to yet another Mindustry video. And this time, I'm back on the more powerful machine. In fact, way more powerful than it should be. And I'm also here with some logic. And this time, the logic is actually useful. So, I need to talk a bit about what we had in logic. So far we've had a way to play games in logic. We could measure power in logic. Uh, we could type in logic. We even had a quote-unquote OS, and I wasn't the one to make it. I made my own specification, and now I've come to this. So what is this logic? Well, this is a impact reactor testing suite. So I made this one in maybe 30 minutes tops. So what this logic is meant to do is it's meant to measure the performance of a scrap impact, or actually any impact reactor, but it measures for scrap by default, so it measures scrapacts. And all you need to do is to fill up a vault with scrap. You link up this large power node to the scrap impact you want. You delete all the batteries inside of the impact, replace them with nodes. And then you put some large batteries on the outside. Now, you might be thinking, hey, 5 large batteries, that's not going to be enough. You see how much power down here there is? That's like 500k, right? That's 500k. But this alone should be like 250k. There's no way that... Oh. So yeah, there's a bit of JS modification going on here. I changed every larger battery to store 20 billion power. Now, that's intentional. I just didn't want to place more blocks, use up more RAM, use up more CPU that way. That's just very not advisable. So let's take a look at how this logic works. Actually, let me host the game so that we can check the logic while the game is running. As soon as I press this button, multiple things are going to happen. So this diode is going to be enabled, and all the power here is going to flow over into these batteries. Not only that, but these unloaders are going to be enabled. And because the unloaders get enabled, rather become enabled, scrap starts flowing in and the impact reactor starts up. So let's start it right now. We had 1,000 scrap here. So the code isn't that large. So we have a quantize option, which is just there to format output. We check if we've pressed the button yet, and we have pressed the button. So unloader 1, unloader 2, all of this gets disabled by default. Then when we press the button, it gets enabled. We wait for 10 seconds because there's an inrush from the batteries and it just takes a long time. Then it's an improvised wait instruction. I know we have a wait instruction, but this is supposed to work in version 6 as well. Then we check when the power input becomes equal to power output. We record the storage both sides have, then record the delta time of break even. That's what BR/2 means, break even. And then we start checking the scrap in volt. If it's larger than 0, it's gonna keep on waiting. And then when the scrap runs out, it's gonna wait until the power input starts to become equal to power output, so it drops below. It's gonna take quite a long time, but no worries. That's how storage really works. Then we start some formatting. We turn our delta time into seconds. We take all these variables that we need, and then we calculate the remaining time, the remaining power that we had at the moment of break even. Then we record how much power we've used from the source. Then we calculate how much power we've generated, the total runtime, and then the effective power. Then we quantize all that and then we print it. So, of course, our impact has already finished. Our 1000 scrap has already went, and we already have our data. So this impact reactor, this one was made by Sirius, ran for 115 seconds and broke even at 36. Meanwhile, it managed to generate 500,000 power, and yeah, you can just steal all this. So I'd be thinking, why is this last field not filled in? Well, you see, uh, you need you can add more volts into the mix, because you can see this effective power here. It's 4,000 power. Now the peak power usage here was the peak power balance here was 7.4k or something, uh, not 4.3. But this is basically like average power over the entire runtime. So so if you really wanted to, you could add more. You could add more scrap. You could attach them to the holds. The only limitation is that you have to attach them to this one, and you could use this for main reactors. This one was taken from Discord. Sirius graciously provided it to me, and the schematic is going to be in the description, or at least link to the schematic. I could share the entire schematic, but I'm just going to leave a paste pinned link. And as always, thanks for watching. Leave a like if you want to see more of this kind of logic. And I'll see you guys in the next video.